Good evening, viewers. Today we are going to see an important topic in communication theory or communication systems. The frequently used term, which is called impulse response. So, what is it? Mathematically, we have so many things. Most of the time, the mathematical expressions uh, we will be able to solve, but the practical meaning of impulse response, practically, what's the meaning of it, why we always test with impulse response. So impulse, practically we cannot generate. So we all know that an impulse, say this is x-axis, this is 0 at time t equal to 0, that is within no time you have some amplitude, and within no time it comes down. So this is that is within no time it has some amplitude, and the just next moment it is 0. So we cannot produce such kind of signal, that is called impulse in time domain. But practically, when we are arguing about impulse, we can always deal with a very short pulse, say a pulse, very short pulse. This will have some a very big range of frequencies. As the t tends to 0, you will get impulse. Okay, that is there. Now the important thing about impulse is, within no time we have some amplitude of the signal, and it comes down the next moment. So defining the signal itself is very difficult in the practical sense. So we will go for the ideal case. So ideal case, this impulse, ideal case means at t equal to 0, at t equal to 0, you see some, say, unit impulse means magnitude 1. Okay. So at t equal to 0, you see amplitude, the next moment, within no time, it comes to 0. So that's the view. If you check out for the frequency domain analysis of the impulse, it contains all the frequencies right from minus infinity. This is frequency domain analysis. So it starts from minus infinity plus to plus infinity. That means I try to say it contains all the frequencies. How negative frequency and all, we are not going into that mathematical expression and proof, all those things. So any system, generally it will be switched on at the particular moment. So usually you can see the step function, not a unit impulse practically. But we can impinge a very short pulse, very close to impulse, but not impulse. So that short pulse, as the t tends to 0, the number of frequencies involved in that signal goes to infinity. That means it contains all the frequencies, right, from minus infinity to plus infinity. That's the meaning. Okay. Now, what is impulse response? Suppose I design an amplifier, a video system, an audio system, or say an optical system which contains electronics, all those things. Suppose I have some system we do not know, some electronic system. Uh, so this is some system. Okay, this system will have its own bandwidth. So first we will consider a regular. It has some bandwidth ranging from, say it's an 30 megahertz. It supports 30 megahertz to 300 megahertz. You assume like that. That is, this system will allow. Basically, it can be thought of as a band pass filter. Allows from 30 megahertz to 300 megahertz. Generally, we go for the time frequency response by connecting a source and an oscilloscope at both the ends, and we used to test for each and every frequency. That is one way. Second way, we can go for practically a spectrum analyzer. to check out what are the frequencies the system is allowing. But what is the input that we have to give into the system? Suppose if you give a unit impulse, you are giving a unit impulse system. So okay, this this is unit impulse system. If you are giving a signal like this, that means what? You are giving all the frequencies right from minus infinity to plus infinity theoretically. So practically I can say when the moment the switch circuit is on, when you give an impulse, it allows all the frequencies. That's the meaning. Okay. Now this system input you have all the frequencies, but at the output, because the system bandwidth is from 30 megahertz to that means it is allowing only these frequencies. In all other frequencies it is rejecting. This we can evaluate only when we give the impulse to the system, because we are impinging all the frequencies to the system, but the system allows only this range of frequency. So it acts as a band pass filter. Sometimes say a particular system can have, it can support from 30 megahertz to 300 megahertz, then say 310 megahertz to 320 megahertz, like that. So between 300 and 310 the system is not allowing, it is rejecting that frequencies. 310 to 320 it is allowing, like that. So generally any problem, any communication problem, if you want to see the response of the system, you must give all the frequencies to the system. All the frequencies to the system can be done only with the unit impulse, unit impulse, or it can have some amplitude or impulse function. But generating this kind of signal is impossible. So you can have a very narrow pulse. Okay, so that narrow pulse will have at most frequencies, but ideally not infinity. So you can test the system and you can see the output. Generally if you connect a spectrum analyzer supporting those range, uh, expecting range, you set the with spectrum analyzer, you can see all the response. So this is the worst signal. If I say worst signal means it contains all the frequency. So all the frequency goes into the system, but the system has a particular bandwidth, range of frequencies, and once again some range that depends on the system, the design. Generally it allows a range of frequency. We can view as a system as band pass filter. So at the output you will be getting 30 megahertz to 300 megahertz. So all of the frequencies are rejected by the system. That means even though we have given all the frequencies to the system is not allowing. So this is called impulse response of the system. Okay. Therefore, we can evaluate any type of system, any type of communication equipment impinging with a unit impulse signal and checking out the response for it. Hope you have understood the basic idea of impulse response. Thanks for watching this video. Nandri.